Hey, math friends. So our learning target today is I can review Unit 5. So everything in Unit 5. All right, here we go. First learning target. I can estimate a square root and graph a square root on a number line is our first learning target. No calculators on this one. You can clearly see that on 1, 2, and 3, I have no calculator written in. So obviously if you're in class, that would be a little bit easier to facilitate. But the square root of 11 would be between the perfect square of the square root of 9 and the perfect square of the square root of 16. The square root of 9 is 3, and the square root of 16 is 4. So the square root of 11 is somewhere between 3 and 4. It says to estimate to the nearest tenth. I'll be super flexible on that, as if you can just estimate it between the two integers that it lives between, the integer of 3 and the integer of 4. So it's 3 point something. That will be sufficient right now in our work, just being able to figure out the integers that it's between. Question 2, same game. Square root of 68 is actually not a perfect square. It's an irrational number. So it's between the square root of 64, which is a perfect square 8, and the next square root would be the square root of 81, which is a perfect square 9. So the square root of 68 lives somewhere between 8 and 9, the integer of 8 and the integer of 9, so it's 8 point something. Again, you do not have to round to the nearest tenth as stated. All right, next problem. This negative on the outside simply just means that we're going to take the opposite of whatever our answer is. Now, we know that it can't be on the inside, right? Because that's just an impossible, that's a imaginary number system. So that would be coming up in like algebras 2 and 3. But so we're just going to simply take the opposite. So now we want to go from least to greatest, because we're in the negative number. We're on the left side of 0 right now. So least to greatest happening here. Always least to greatest, really, is what I should say. So negative the square root of 100 would be less than, and the one that's greater than would be negative the square root of 81. Notice I'm going least to greatest because of the negative number world. We get a negative coming out of here, and the square root of 10 would, our square root of 100 is 10. We get a 9 coming out of there because the square root of 81 is 9, and we're going to take the opposite of that. So our answer is going to live somewhere in between the square root of, I misspoke, the integer of negative 10 and the integer of negative 9. So it'd be negative 9 point something. Notice I said negative 9 point something. It's in between those because we're on the left side of negative, left side of 0. I'm sorry, I misspoke again. Left side of 0, not the left side of negative. Yikes, come on, Volkman. Square root of 32 lives between the square root of 25. We're back in the positive number system here. And the square root of 36. So the square root of 35, or 25, I might have said 35. I apologize again. Square root of 25, here we go, pick it up, is 5. The square root of 36 is 6. So our square root of 32 lives somewhere in between the integer of 5 and the integer of 6. Something like 5 point something. Again, I'm being pretty flexible in your rounding there. So same type of game. Under the umbrella of the learning target, now can you graph it? So can you estimate it, and then can you graph it on the number line given? So first example A, we're talking about the opposite of those. So we're going least to greatest here. So it'd be the negative the square root of 4 and negative the square root of 1. And negative the square root of 4 is negative 2. And negative the square root of 1 is negative 1. So the answer lives somewhere between negative 2 and negative 1. Somewhere between negative 2 and negative 1. So negative 1 point something. So that A is going to live somewhere in here. So I'm just going to kind of write it up above right now, and I'll come back and assess about like, specifically where should I put it. All right. So going down to B, B looks a little bit easier for me because we have that perfect square. We're going to take the opposite of the square root of 16. Well, the square root of 16 is 4, and then we're going to take the opposite of that. So the opposite of that would be the letter B would be sitting right here at negative 4. Square root of C, there's this rule in mathematics that allows us to take the square root of the numerator and the denominator. So square root of 4 over the square root of 16. So we give the square root to the top, we give the square root to the bottom, kind of like the idea of distribute, gives us 1/4. The fraction 1/4 is the same as 25 cents. So 25 cents would fall about right here. Whoops, that is actually C. Would fall about right here, 25 cents. All right, going to D. The square root of 5. The square root of 5 lives between the square root of 4 and the square root of 9. The square root of 4 is 2, and the square root of 9 is 3. So our answer is going to live somewhere between 2 and 3. Somewhere between 2 and 3 would be D. So I'm going to put that up here for now, and we can move it down in just a minute if we find the exact place for it. All right. The square root of 18. The square root of 18 lives somewhere between the square root of 16 and the square root of 25. So the square root of 16 is 4, and the square root of 25 is 5, so it lives somewhere between 4 and 5. So we know that E lives somewhere between 4 and 5. All right. And then the square root of 22 lives somewhere between the square root of, same, 16 and 25. It lives in that same pocket of between 4 and 5. So F lives in that same pocket, but F is slightly bigger because 22 is slightly bigger than 18. So F would be maybe somewhere right here. All right, so now I'm just going to slide these in because we don't have any other competition happening here. I need that mouse. So E lives there, F lives there, D lives, we said D was between 2 and 3. D lives there, A lives there. So that is the representation of those 6 on the number line using estimation with square roots. That was your learning target. Kind of a lot going on there. You'll notice on the left it says no calculator. So you should be doing that through simple, what we call, not simple, it's not simple, but estimation. All right. Next learning target, I can determine if a number is rational or irrational. I can classify the sum or product as rational or irrational. It does say no calculator as well here. So the square root of 121 is 11. So that would be rational. This is the square root of 1 over the square root of 16. And the square root of 1 is 1. And the square root of 16 is 4. That's a nice fraction. So we're going to call that rational. This is a nice repeating decimal, so we're going to call that rational. We have a yucky square root here. This is actually a rectangle, so that's irrational. We have a nice decimal here. This is a terminating decimal, a nice decimal in terms of a math standpoint. So we're going to call that rational. Now the next one is the square root of 1,000. So thinking about what number when we multiply by itself gives us 1,000. We know that 10 times 10 is 100, but is there a number that we multiply by itself to get 1,000? So the square root of 1,000 does not work out beautifully. It's more of a rectangle. This one is actually going to be irrational. That one's a little tricky. If you want to temporarily throw that in your calculator just to kind of check that one out, that you get a decimal, that would be fine with me. 12/17 by definition is rational. That's actually the definition of rational, is that you can write it as the quotient of 2 integers, which means write it as a fraction. The square root of 18 is actually a rectangle. If you think about the factors of 18, it's 1 times 18, 2 times 9, 3 times 6. None of those make a rectangle, or none of those make a square, rather. So this one's irrational. Has nothing to do with the negative out front. It's just that you cannot make a square out of 18. 0 is rational. Anything involving pi is irrational. Pause the video at any time. So if this is going too fast, of course, you just need to push pause. I'm just going to keep going at my pace because I'm covering everything in the unit. This is just an integer. Of course, it can be written as a fraction. Just throw a 1 under it. And the square root of 16 is 4, which is rational. So I'm going to go back through and highlight which ones did we say are irrational. Because there's an infinite number that are rational, but there's the irrational ones often are easier to pull out. So anything that's a yucky square root, like the square root of 11, the square root of 18, those are rectangles. Anything involving pi and the square root of 1,000, not as easy to see, but if we think about what number times itself gives us 1,000, it really just doesn't mathematically work out. So those were the 4 involving irrational. So anything with pi and anything that is a rectangle, not a square. All right, coolio. And that last problem down here, these ones are a little bit trickier, but anytime there's an irrational involved, typically you get an irrational output. There, of course, in math, there's always that exception, and we'll talk about that. But this is the square root of 4, which is 2. The square root of 11 is irrational. So anything involving that is going to be irrational. Number 8. Square root of 49 is 7. That's a nice rational number. And just adding the integer of 4 is 11. That's a rational answer. Number 9 has 2 irrational numbers being multiplied, but the key is there's a rule in math that says we can multiply the product of the insides of those. So that becomes actually the square root of 100. And now when we take the square root of that, we do actually get 10. So this becomes rational. Although we started with an I and an I through multiplication, when we use the property that we can multiply the 2 of those and then take square root, we end up with a nice, beautiful rational number of 10. The square root of 16 is 4, and we multiply it by the square root of 3, which is really icky. It's not a square, it's a rectangle. I don't know what happened to my screen here. I'm going to have to pause for a minute. You guys can catch up. I lost my screen. I don't know where the screen went. Sorry about the huge delay there. I'm working off of a Surface and I lost the screen. Like it just went dead on me. Okay. So when we work with an irrational here, 4 times any irrational number is actually going to give us an irrational output. So those are a little more complicated. Just more of a problem solving strategy is what I would recommend there. All right, question 11, simplify. We did not cover these these will not be on the test, step 1, and we did not cover these in the units. So I think I'm actually going to, I think I'll cover them, but just be aware that they won't be on the test, but just good things to know. The square root of 48 breaks into, at least this year, they didn't get covered. Pull out any common factors. So 16 goes in there. I'll just start with 4. So the square root of 4 times the square root of 12. And the square root of 4 is 2. And then the square root of 4 times, or square root of 4, which is 2. 12 breaks into the square root of 4 times the square root of 3. I'm pulling out things that are perfect squares. So that's 2 times 2 times the square root of 3, which is 4 times the square root of 3. Now that's pretty fast, but basically we're using the same idea of like a factor, common factors out of the tree factor process, but we're using perfect squares instead. So we're pulling out the perfect squares. So I'm left with 4 times square root of 3. Again, not on this year's assessment, but I'm going to just throw it in just for extra learning anyway. This definitely is coming up in future mathematics. This one, I'm going to also pull out a 4. There are other factors we can pull out of there, but 4 times the square root of 8. So that's negative 2 times 2. And the square root of 8 breaks into the square root of 4 times the square root of 2. Lots of square root of 4s going on there. So that's negative 2 times 2 times 2 times square root 2. All of that becomes negative 2 times 2 times 2 is negative 8 square root 2. Square root 2 is irrational, so we can't break that down any further. So I know that's pretty fast. You can pause it if you want. Super important future skill, just not hitting us in the Minnesota standards right now as heavy as a power standard. Square root of 75. I know that 25 is in there, so I'm going to pull out 25 times the square root of 3. Remember, we can break the square root to the numerator and the denominator. And then in the bottom, I have the square root of x squared, which actually will cancel each other out. So as I start to break that down, that becomes 5 square root 3. And in the denominator, the square root of x squared, the square root and the square root and the square cancel each other out, which is x. We can talk about that again in another video. But that's the gist of how we simplify a square root for future math. Again, not covered in the next test, but good to talk about anyway. All right, question 14. Sorry, this video is going to get a little longer because I had that little issue with my Surface. We're going to plug in a 3 here for x. In the numerator, I have the square root of 18 over 3. And using the skill that we just worked on, and most likely on the test, I would have you type this in maybe decimal form. So, but let's just try it. That's the square root of 9 times the square root of 2. That would work because 9 is a common or a perfect square root. Divide by 3. And this really turns into 3 square root 2 over 3. And 3 divided by 3 is a nice 1. So we end up with just the square root of 2 coming out of that question, just square root 2. Yay. Again, question 14 wouldn't be covered in that capacity of having to break down the square root, but just really good future math to cover anyway. Little bonus for you today. Inside of here, we have the square root of 16, and then we're going to take the opposite of that. And we're going to add, once we do that, we're going to add 19. Remember, PEMDAS says we have to do all square roots, absolute values, and parentheses first. So the square root of 16, of course, is 4. We're going to reattach the negative, and then we add 19. So we end up with 15 as the final output there, positive 15. All right, y'all. Question 16. We're going to substitute 15 into the absolute value. So we have 50 plus 15 minus 20. Inside of here, you know, that's a grouping symbol. We have to do that first. I was just talking about that this functions like a parenthesis. It has to happen first. So inside of there, we get the absolute value of negative 5 when we simplify, which gives us 5, positive 5. We're just asking how far away from 0. It's just a distance. So we have 50 plus 5 is 55. Check it out. If you need to rewind, do it. If not, we keep moving. You're going to have to just push pause when things go too fast. All right, especially if you need to write it down, right? You're just going to have to press pause. This is going to be another example of we simplify that square root. Of course, you could always well throw it in your calculator if it's asking for decimal form on the upcoming test here. All right, so as we break that down, the square root of 12 is going to break into the square root of 4 times the square root of 3, because the square root of 4 is beautiful in terms of rational square roots. So we get 3 plus 2 times 2 square root 3. That becomes 2. So that's 3 plus, order of operations here, 4 times square root 3. And that is the best we can do on that output. You also could have that in decimal form, but I just wanted to show you how that would work with that new learning we just talked about. And you could throw that in as a decimal as well. All right, couple left here. Question 18, we're going to solve the equation containing square roots and fraction bars. Coolio. All right, here we go. Our job is to isolate for x. The operation on this side here is divide by negative 2. So we're going to multiply this entire quantity by negative 2, copy, paste, copy, paste. So if we haven't used it, drag it down. And on the right-hand side, we get positive 20. Coolio, coolio. Build house, build fence, clean yard, clean yard. We're going to subtract 8, or the hand method. We go 3x, drag it down. 20, take away 8 is what? 12. Boom, got it. So first thing we did is we multiplied both sides by negative 2, copy, paste, copy, paste. Then we drag it down. Then we subtract 8, copy, paste, copy, paste. The final step here then is to get rid of this multiplication by 3, so division is the operation. We end up with x equals 4. Now, because of the time it takes on the video, you need to. It's like super, super essential that you plug back in and check. But I'm going to skip that step because we're already at almost 20 minutes. Next problem, number 19. Build house, build fence, clean yard, or the hand method. Take your hand, cover that right there, wherever the variable is. Cover it, cover it, cover it. Boom. We're going to add to, copy, paste, copy, paste. We get 6 on the left side. If I haven't used it, drag it down, coolio. Now, how do we get rid of the square root of 3x? We square it. The opposite of squaring and square rooting are inverses or opposites. Whatever we do on one side, we have to do on the other. So we end up with 36 is equal to, these just kill each other, the square root and the square. Boom, cancel. That 3x just drops out of there then. And then the operation to get rid of this 3 through multiplication, we need to divide, copy, paste, copy, paste. We get x equals 12. Again, it is your job to plug that back in and check. Okay, you're on your own for that because I'm going to try to just keep this video going. Boom. Question 20. Our job is to solve and check. Build house, build fence, clean yard, or the hand method. Take your hand, cover that variable. Your job is to get rid of that subtract 42. The opposite of subtracting 42 is to add. Copy, paste, clean that yard. All right, coolio. If I haven't used it, drag it down. And we're left with positive 40 on the right-hand side. Boom. Now, how do we get rid of this square? Well, the opposite of squaring is to take the square root, copy, paste, copy, paste. So you end up with y is equal to the square root of 40. Now, when we take the square root of 40, you have two options. You can use that strategy that we talked about, although that would be tricky to type in on our next test. Or you can throw it in your calculator and take the square root of 40. And when you do that, let's round it to the nearest hundredth for now. But I'm going to grade these by hand anyway. So whether you give it to me, they're tenths or hundredths, it doesn't really matter. But I'm going to go to the hundredths place. In my calculator, I get 6.32. And notice it says there are two answers. So I'm going to write down the positive 6.32 that would work and the negative 6.32 that would work. Hint, there are two answers. Make sure that you account for that in your answer. So final is y equals 6.32. Now, just for a fun bonus, is you could have said the square root of 40 breaks into the square root of 4. It's supposed to be an arrow. The square root of 4 times the square root of 10, which is plus or minus 2 times square root 10. Those are equivalent answers, but we will hold off on that for now because it's not going to be our priority standard for this year. Moving on, question 21. Boom. Here we go. Build house, build fence, clean yard, or put your hand on that m squared. We subtract 9, copy, paste, copy, paste. You maybe can't see that m squared now. All right, coolio, let's do it. So we're trying to isolate, get m alone. So we do that. M squared is equal to negative 4. How do we undo the square? We take the square root of both sides. So I take the square root of the left, and then I go take the square root of the right. Uh-oh. As I go to take the square root of right, notice that there is a negative sitting on the inside of the radical. That cannot happen in math. You cannot have a negative on the inside in this course. When we talk about imaginary number systems, then there's ways to break that down. So right now, because there's a negative on the inside, you have to say that there is no solution to this equation. And you really do need to type no solution into the box or something very, very equivalent or close to that. All right, here we go. Let's wrap it up. Last page then. A pool is 45 feet wide and 30 feet long. You swim diagonally across the pool. How far did you swim? Let's check it out. So a pool is 45 feet wide, 30 feet long. It doesn't matter which way you do that. And you swim diagonally across the pool. How far did you swim? Ooh, looks like the Pythagorean theorem here. I guess it doesn't specifically say that we have a rectangle, but we're going to assume that. That was a poorly written question by me. So we have Pythagorean theorem says that a squared plus b squared is equal to the hypotenuse known as c squared, which is that diagonal of how far you swam. So using the Pythagorean theorem now, we're going to solve for that unknown side length. This only works for right triangles. So we get 900 plus, oh boy, I don't know what 45 squared is. Help me, help me, help me. Ooh, that's massive. 2025. Check it out. Why don't you pause the video and verify? Verify team. Send in your verify team and make sure that you got that. So we're looking for how far did you swim that diagonal, the length of that, using the Pythagorean theorem, because we have a right triangle. So undo this square then. We're going to take the square root of both sides. And we get c is equal to the square root of 2925. Square root of 2925. I am going to just round to the nearest whole number for now because it doesn't say anyway. So around 54. So the c length is approximately 54, and the units on that would be feet. That is the distance in which you swam diagonally across the pool. So there's the learning target of the Pythagorean theorem. I'm going to pause video for something and check for a sec. Okay, next question. Is this a right triangle? Use math to prove your answer. Lots of kids will just look at that and assume that it's a right triangle. The question is this truly a right triangle? The symbol is just more of a question mark. So just make sure that's not confusing. So is it true that 8 squared plus 14 squared is equal to 16 squared? True or false? So it just does the left side equal the right side on the Pythagorean theorem. So 8 squared plus 14 squared, that's 260. And 16 squared is 256. So does the left side equal the right side? Nada. So that is not a right triangle. That's, make sure you're using math. So don't just assume that it is. Okay. Find the unknown side length. That's using the Pythagorean theorem as well. So we have a, b, and a c here. So we have 4 squared plus 9 squared equals x squared. Our hypotenuse, of course, is the side opposite. So we get 16 plus 81 equals x squared. Now we're going to take the sum of the left side, which is 97 equals x squared. Our job is to undo the square, so we're going to take the square root of both sides. So we get x equals the square root of 97, which is just slightly less than the square root of 100. And I get 9.8, I'm not around to the hundredths this time, 9.85. It doesn't specifically say, but I'm grading these by hand anyway, so that would be fine. So it'd be plus or minus 9.85 for the length of that side. And finally, wrapping up the final here is, and I did things a little bit out of order. That's why I paused the video, because I had the slides out of order. But find the distance between the 2 points using the distance formula. So we have a data point here and a data point here. Here's my y-axis and here's my x-axis. So this data point is located at 1, 2, 3, 4, up 3. And this data point is at 1, 2, 3, negative 4, negative 2. Now you need to find the distance between those 2 points using the distance formula. I know some kids also want to use the Pythagorean theorem on that just to confirm their answer. So I'll give you a chance to work. Distance formula. All right, hopefully you had a chance to work here. So the distance formula, as you know, is the square root of x2 minus x1 quantity squared. So you're kind of undoing some slope stuff. And then y2 minus y1 quantity squared. All right, with that said, then we're going to plug in. So the distance would be that we're going to subtract our x's. So 4 minus negative 4 squared. Watch your signs. Subtract our y's. 3 minus negative 2 squared. Make sure you do it in the same order when you do that. This is going to be a plus there. So that's 8 squared is 64 plus 5 squared, which is 25. So we have the square root of 89. And the square root of 89 is, when I type in my calculator, square root 89 gives me 9.43 plus or minus 9.43. And again, I'm grading those by hand. So you're rounding, there'll be some flexibility in rounding there. Excuse me. And the final is to use the distance formula to get the distance between the 2 points below. Coolio. All right, here we go. So using the distance formula, we're going to subtract our x's, x2 minus x1, and then we square it. Cool. Then subtract our y's, boom, and square it. So our x's would be, these are my x's, so 5, and just make sure you're doing it in the same order. Once you start, you got to do it in the same order. So 5 minus 2, quantity squared, and 4 minus 1, quantity squared. Cool. So that ends up with 3 quantity squared plus, 3 quantity squared. That ends up with 9 plus 9 is the square root of 18. And for the square root of 18, what do we get? Square root of 18 is 4.24 plus or minus 4.24. Cool. So that's the distance formula. Now I'm going to backtrack real quick here and just use my verify team, that if I quick ran the Pythagorean theorem on this, I just thought of this. If I quick ran the Pythagorean theorem on this, would I get the same answer? I should. So that's 1, 2, 3, 4, 5 squared. There's my 5 squared. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 squared. And I have it, the square root of 89. Cool. So that is your learning target 4. I can review Unit 5 and get myself ready for that upcoming test. Have a glorious night. Sorry about my mistakes in there and the delay on my computer screen. I didn't mean to make the video so long. Goodbye.